All right, let's unpack this. Today, we're taking a truly in-depth exploration, a real deep dive into a technology that, well, it might not be a household name exactly, but it really underpins the very fabric of countless businesses worldwide. We're talking a SAP Asia. It's a foundational, really powerful system that, honestly, it redefined what's possible in enterprise data management.
Yeah, it really did. And what's fascinating here is that while SAP HA is incredibly impactful, its inner workings can sometimes seem like, a dense forest of acronyms and technical jargon. It
Yeah.
can be quite intimidating.
Absolutely.
So our mission, if you will, for this deep dive is to, well, unravel those layers.
Right.
We want to provide you with a clear roadmap through a lot of that complex information. We'll start with the basics, its fundamental definition, explore its core operational mechanics.
How it actually works under the hood.
Exactly. And even demystify some of its, let's say, unique licensing quirks. The goal is for you to walk away with a robust understanding that goes, far beyond just reciting definitions.
And to do that, we've basically gathered a stack of expert-level sources, really detailed breakdowns of HANA's architecture, its intricate file systems, and those critical licensing models you mentioned. Our goal really is to give you a rapid yet incredibly thorough understanding, all without feeling, well, overwhelmed. We're aiming for those moments where complex pieces just click into place.
Those aha moments.
Exactly, revealing just how this technological giant functions from the inside out, hopefully providing those genuine aha moments that make learning truly stick.
The genesis and evolution of SAP HANA, from idea to industry standard.
So let's start right at the very beginning, unwrapping the name itself. When you hear HANA, what does it actually stand for? It's one of those acronyms that gets thrown around a lot, isn't it?
It is, and it actually has two meanings, which is interesting. First, it can stand for Hasso's new architecture.
Okay, Hasso Plattner, one of the SAP co-founders.
Precisely. A direct nod to his vision and pivotal role in its conception. But the other, maybe more widely known meaning is high-performance analytical appliance.
High-performance analytical appliance. Okay, both names kind of give you a hint right away, don't they? Innovation and speed.
They really do. They signal its core intent right from the start.
But what's truly surprising, I think, when you consider how ubiquitous it is today, is just how recent its origins are. This foundational idea, this, well, revolutionary concept of storing all the data directly in memory for incredible speed.
Instead of spinning disks, yeah.
Right. Rather than relying on slower disk storage that only started to germinate around, 2006?
That's right, 2006. Which, in tech years, especially for something this foundational, isn't actually that long ago.
No, it really isn't. It makes you appreciate the speed of innovation in this space.
It's quite incredible how quickly that initial kind of audacious idea evolved into something market-ready. Following that foundational thought in 2006, SAP moved with, well, remarkable agility. By 2010, they released what they called a ramp-up version.
Okay, ramp up, so not for everyone just yet.
Exactly. For those unfamiliar, a ramp-up version isn't a general public release. Think of it more like an intensive real-world trial, almost like a highly exclusive pilot program.
Right.
This early software was provided very specifically to a select group of hardware vendors. Major players like IBM and Fujitsu were among the first.
Okay, so they got the early look.
They did. Their task was rigorous.
Yeah.
Put this nascent SAP HANA software through its paces on their specific hardware. Identify bugs, performance bottlenecks, any compatibility issues.
Stress testing it, basically.
Absolutely. This phase is absolutely crucial in complex software development. It allows for that real-world stress testing and provides invaluable feedback before you roll it out wider. It's how they iron out the kinks, ensure compatibility with different hardware, and essentially validate the product in a controlled yet demanding environment.
Makes sense. You wouldn't want the first public release full of bugs.
Definitely not. So building on that critical feedback and the necessary refinements from that ramp-up phase, SAP finally achieved general availability for SAP HANA 1.0 SPS 03 in 2011.
SPS 03. Okay, SPS stands for?
Support Package Stack.
Got it. Support Package Stack.
Yeah, and you might wonder, why SPS 03? Why not start at 01 or 02?
Yeah, I was wondering that.
It's a great question, and it really speaks to the, well, meticulous iterative nature of enterprise software releases. Those earlier versions, SPS 01 and SPS 02, were essentially internal builds, or maybe very limited release builds, perhaps for internal SAP testing, specific customer pilot projects, or even the final stages of that ramp-up program we just talked about.
I see. So not quite ready for prime time?
Not quite. SPSO3 was the first version they deemed stable, robust, and, feature complete enough for widespread commercial adoption. It really marked H&O's true entry into the mainstream enterprise market, ready for production use. This structured approach, it minimizes risk for customers adopting complex new tech.
Right, ensuring they get something battle-tested.
Exactly.
That progression makes perfect sense. And once it was generally available, HANA's expansion beyond just being a standalone database was, well, rapid and maybe more importantly, incredibly strategic. Just a year later, in 2012, SAP introduced the SAP HANA Cloud Platform, which we now know as SAP Cloud Platform, right?
That's right. Now called SAP Business Technology Platform, or BTP. But yes, that was the beginning.
Okay, BTP. Good clarification. This was a huge strategic step, wasn't it? Signaling SAP's move into cloud services, offering HANA's power without needing all the on-premise hardware.
A very significant step, yes. Made it much more accessible.
But perhaps the really critical test, the one that truly proved HANA's capabilities, came next. That ambitious project of moving their entire SAP business suite.
The whole kit and caboodle.
Yeah, the very core of enterprise operations systems like ERP, ECC6, SRM, CRM, all of it, onto the HANA database.
That was massive.
It wasn't just about showing off a fast database, was it? This was about proving HANA could handle the immense real-time transactional and analytical demands of an entire business suite all at once.
Right. Compatibility, scalability, performance under heavy real-world load from all those different business processes.
It ultimately proved HANA wasn't just fast. It was a robust, reliable, high-performance foundation for an enterprise's entire digital core.
And this brings us to a point that, well, it often causes significant confusion for people trying to navigate the SAP ecosystem. It's a really critical distinction. In 2015, SAP released SAP S/4HANA.
Okay, S/4HANA.
Now, here's the crucial clarification. S/4HANA is an application. It's a comprehensive suite of enterprise management software. HANA, as we've been discussing, is the underlying database technology.
Got it. Application versus database, like Word versus the operating system.
Exactly like that. Think of your laptop hardware, the OS like Linux, and then your word processors, the application. They're distinct, deeply interdependent.
Right.
Before S/4HANA, applications like ECC6, SRM, or CRM offered customers flexibility. They could run on various traditional databases, Oracle, DB2, SQL Server, or even SAP HANA.
So you had choices back then.
You did. It let organizations leverage existing investments in other database tech. However, with S/4HANA, SAP made a definitive strategic move. This is a game changer.
S/4HANA only supports the HANA database.
Only HANA. No other options.
No other options for S/4HANA. This decision was pivotal because S/4HANA was completely re-architected, redesigned specifically to leverage HANA's unique in-memory power, its columnar storage, its ability to combine transactional and analytical processing.
So it needed HANA to work properly?
Essentially, yes. Without HANA, S/4HANA simply cannot deliver its intended performance and innovation. If we connect this to the bigger picture, this distinction is absolutely vital for understanding SAP's entire modern ecosystem and its strategic direction.
Okay.
It's foundational knowledge. It clarifies why HANA became so central to SAP's strategy and how S/4HANA differs from the older systems. It created this tightly integrated, optimized stack designed for, well, unparalleled performance.
And it basically forced customers onto SE if they wanted the latest and greatest with S4? That was the effect, yes. It wasn't just a technical upgrade. It was a complete paradigm shift for SAP and its customers.
Wow, that really clarifies the strategic imperative behind ADA. Makes perfect sense that to unlock S4's power, you needed HANA's specific capabilities. So, moving further along our timeline, 2017, SAP kept broadening HANA's reach, didn't they?
They did. They released SAP ADA Express Edition.
Express Edition, what's that about? Sounds like a smaller version.
Exactly. It's typically a free-to-use, smaller footprint version, often aimed at individual developers, students, small businesses, people looking to get hands-on experience, experiment, build new apps without a massive upfront investment.
Lowering the barrier to entry, that's smart.
Very smart. And in that same year, 2017, they unveiled a major, highly anticipated update, SAP HANA 2.0.
ADA 2.0, so more than just a version bump.
Oh, much more. It represented a significant architectural evolution. It brought a host of new features, enhanced performance, and a refined approach to how ADA operates, really setting the stage for its next generation.
Okay, and before we jump into 2.0's architecture, you mentioned something about an appliance model earlier. For the very early HANA versions.
Ah, yes, that's important context. Building on that, it's vital to understand the appliance concept from HANA's early days. Up until HANA 1.0 at SPSO 5, HANA was primarily sold as an appliance.
An appliance, like a refrigerator.
Kind of like that, yes. In an enterprise context, think of it like this. You don't buy the complex cooling software for your fridge separately and then try to install it on any box you have lying around.
No, you buy the whole fridge, ready to go.
Exactly. You buy the whole unit hardware and pre-installed, optimized software, perfectly integrated. Similarly, with early HANA, you couldn't just acquire the software license and install it on any server you chose.
Really? So you had to buy the hardware from SAP too, or specific vendors?
You had to purchase the entire system. The HANA software pre-installed and rigorously optimized on specific certified hardware from a select group of vendors like IBM, Fujitsu, and HP initially.
Wow. Okay. What was the significance of that? Why do it that way?
Well, the significance was immense at the time. It ensured customers received a fully integrated, highly optimized system right out of the box. It minimized potential compatibility issues, eliminated the complexities of tuning hardware and software yourself.
Guaranteed performance, basically?
Maximize performance, yes. Because the hardware and software were designed to work in perfect symbiotic harmony, it guaranteed a predictable high-performance outcome.
Okay, I can see the appeal, but the downside.
The downside, as you can imagine, was a significant limitation on hardware choice and, well, a potential for vendor lock-in. Companies might have existing relationships or preferred hardware vendors that weren't initially certified.
Right, less flexibility?
Much less. Over time, SAP recognized the need for greater flexibility and broader market adoption. So they strategically opened up HANA's support to, well, almost all major hardware vendors.
So they moved away from the strict appliance model.
They did. That transition was pivotal. It made HANA much more flexible, more accessible to a broader range of enterprises. It allowed them to leverage existing hardware partnerships, choose the best fit for their infrastructure, and integrate HANA more seamlessly into diverse IT landscapes, moving away from that rigid appliance to a more adaptable software solution.
Understanding HANA's architecture. Single versus multi-tenant deployments.
Okay, so that brings us nicely into HANA's architecture. You mentioned HANA 1.0 and 2.0. It sounds like we should think of them less like one continuous thing and more like maybe two distinct generations, or as you put it, two flavors of HANA.
That's a good way to think about it, yes.
Yeah.
Each represents a significant leap, but they have their own lineages, their own characteristics, like different iPhone generations.
Right, so within HANA 1.0, there was that progression of versions you mentioned, SPS 03, 04, 05, all the way up to SPS 12.
Correct. Each support package stack brought improvements, bug fixes, sometimes new features, incremental enhancements.
But after SPS 12, SAP stopped releasing new support packages for HANA 1.0.
That's right. It signaled a definitive shift towards the next generation.
Which is HANA 2.0, starting its own lineage from SPS 00, and the latest is what, SPS 07.
Correct. As of our discussion, SPS 07 is the latest major update. So these version numbers, while technical, mark distinct milestones, each with unique capabilities and deployment considerations.
Again, and within these evolving versions, a really important architectural concept emerged and matured, this idea of tenancy, single-tenant versus multi-tenant databases.
Ah, yes, tenancy, a really crucial concept, especially with HANA 2.0. In a traditional single-tenant setup, you have a very clear, dedicated stack. One OS instance running one database instance, say, Oracle supporting one application instance, like ECC.
One-to-one. Simple, isolated.
Very much so. Predictable resources, straightforward management. But, multi-tenancy is such a buzzword now, especially in the cloud. This raises an important question. Why would you even need multi-tenancy for something as critical as HANA? Why run multiple applications on a shared database instance? What problems does it solve?
That is a crucial question, especially when you look at how HANA's tenancy support evolved. In the early days, HANA 1.0 SPS 03 up to SPS 08, it only supported single-tenant databases. That dedicated setup.
Right, keeping it simple initially.
But then, here's where it gets really interesting. Starting with HANA 1.0 SPS 09 through SPS 12, and even the initial HANA 2.0 SPS 00, SAP introduced flexibility. They supported both single-tenant or multi-tenant deployments.
Giving people a choice, an overlap period.
Exactly. Letting organizations transition, experiment, maybe manage hybrid environments. But the strategic future became crystal clear with HANA 2.0 SPS 01 onwards, including the latest SPS 07. These versions only support multi-tenant databases.
Only multi-tenant now, so single-tenant is obsolete for new HANA 2.0 deployments.
Effectively, yes.
Sure.
It's considered obsolete in that context. This wasn't just a technical tweak. It was a fundamental shift in how SAP envisions database deployment, resource management, and, well, the future of their cloud offerings.
That move to exclusively multi-tenant from HA 2.0 SPS 01 is indeed a very clear signal, largely driven by cloud demands, optimizing resource use, provisioning services more efficiently. To really grasp multi-tenancy, let's use that apartment building analogy again.
Okay, the apartment building.
You have one large building that's your single overarching HANA database instance. But within that building, you have multiple separate isolated flats or containers. Each flat is an independent tenant database.
Right, individual apartments.
Exactly. And you have what's called a system DB. Think of that as the common services for the entire building, the main power, the elevators, or maybe even the ASCS, the ABAP Central Services instance, in a traditional SAP setup.
Yes, yes, that handles messages and locking.
Yeah.
Right, like the building's intercom and security
A
desk.
good analogy. Vital for all residents, all tenants, but separate from their individual apartments. It ensures they can communicate and sync data efficiently.
Okay, so System DB is the building management. What about the flats?
Those are your individual tenant databases. So tenant 1 might host your ECC application. Tenant 2 could host your BW, Business Warehouse application. Tenant 3 maybe CRM.
And the applications live in the tenant databases, not the System DB.
Crucially, yes. Applications like ECC or BW are installed and run on these individual tenant databases, not the System DB. Each tenant is designed to be isolated. It has its own dedicated programs, reports, screens, its own business data.
So Tenant 1 can't see Tenant 2's data.
Correct. That's the design. Data and operations are separate and secure, even though they share the underlying HA instance and those common services from the System DB.
Okay.
It allows for that high degree of isolation for sensitive business data while still leveraging shared hardware resources efficiently, trying to get the best of both worlds. Consolidation for efficiency, isolation for security, and stability.
So on paper, this multi-tenancy sounds incredibly efficient. Sharing the OS, CPU, RAM across multiple applications within one HANA instance, it's a technical capability that offers huge flexibility, especially in the cloud.
Technically very flexible.
You could, theoretically, install ECC on Tenant 1, BW on Tenant 2, SRM on Tenant 3, all sharing that one HANA instance. But here's the often missed critical insight. While the technical capability is there, it's rarely a good idea for high-volume, mission-critical production systems to run fundamentally different applications like ECC and BW on separate tenants within the same HANA database instance.
Ah, okay. Why not? If the capability is there.
Performance. It's a strategic trade-off. Sharing those critical resources so intensely can significantly drag down performance for each individual application. It's like trying to run, I don't know, a marathon and a sprint race on the same track simultaneously.
Everyone gets tripped up. Resource contention.
Exactly. The overhead of managing resource contention between these heavy-duty apps, one optimized for transactions, the other for analytics, often outweighs the consolidation benefits for production.
So where is multi-tenancy commonly used effectively then?
Where it does shine, and is commonly practiced, is in consolidating different landscapes of the same application. For instance, you might have your S4 HANA development tenant, your S4 quality tenant, maybe a sandbox tenant, all residing as different tenant databases within the same physical HANA instance.
Okay, so dev, QA, sandbox of S4 on one HANA box. That makes sense.
Right. That provides cost savings, simplifies management, offers good isolation for non-production environments. So while the flexibility for running different apps is technically there, performance usually leads organizations to put distinct production apps on their own dedicated HANA instances, even if those instances are managed within a multi-tenant framework for other purposes, like consolidating landscapes.
Got it. So it's a prime example of technical possibility meeting real-world performance limits.
The brain and the backup, memory, persistence, and save points.
Now let's talk about HANA's defining characteristic, the heart of its high-performance claim, its reliance on RAM.
The in-memory aspect.
Exactly. Unlike traditional databases that mostly live on slower hard disks, only loading bits into memory as good, HANA flips that. It stores its entire database, all data, tables, indexes, directly in physical memory, in RAM.
Which is what makes it so incredibly fast for access and processing. Game-changing for real-time analytics, complex transactions.
Absolutely. But this revolutionary approach immediately introduces a critical, almost existential problem. RAM is volatile.
Inherently volatile, yes.
So what happens if there's a power failure, a system crash, an unexpected reboot, without some way to preserve data?
Oof. The entire database would just vanish, gone in an instant. All that valuable business data wiped clean. A nightmare scenario.
Right. So how does HANA solve this massive problem?
That's precisely where HANA's, ingenious solution comes in to ensure data integrity and durability, the persistent layer.
The persistent layer. Okay.
To address that RAM volatility, HANA maintains a complete, up-to-date copy of all its data on the hard disk. This persistent storage lives in two key distinct directories: the HANA Data Directory and the HANA Log Directory.
Data and log.
Correct. These two together are collectively called the persistent layer. And understanding this concept is absolutely fundamental to HANA's reliability. It's actually a very common interview question for HANA folks.
I bet.
This layer ensures data durability, provides the foundation for recovery, guarantees your valuable info isn't lost, even if the volatile memory fails.
Okay, so we have the data in RAM for speed and a copy on disk for safety in the data and log directories. How does this actually work in practice as new data comes in? Let's walk through a transaction.
Good idea. Let's say you're creating a new customer record in your SAP system. Let's call her Eleanor Vance.
Okay, creating Eleanor Vance.
When that transaction happens, new data for Eleanor is generated in memory. The moment you commit that transaction, you finalize and save the changes. That data is immediately written to log directory on disk.
Immediately to the log directory, not the data directory first.
Immediately to the log. It's a write-ahead logging mechanism.
Okay, why the log first? And why two separate copies on disk, data and log?
It's all about security, atomicity, and efficient recovery. The log directory acts as a complete, chronological, immutable record of every single committed change. This ensures that even if the system crashes immediately after you hit save for Eleanor.
The fact that you saved her is already safely on disk in the log.
Precisely. The transaction is durably recorded, making it fully recoverable. It guarantees no committed data is ever lost.
Okay, so the log captures every change instantly. But what about the main HANA data directory? When does that get updated?
This brings us to a truly crucial concept in HANA, the Savepoint.
Savepoint, okay.
While new transactions hit the log directory immediately for durability, the updated information currently sitting in physical memory is periodically synchronized and robustly updated into the main data directory on disk via these Savepoints.
Periodically? How often?
Automatically, and typically every 5 minutes.
Every 5 minutes? That seems quite frequent.
It is. And while you can technically configure this frequency, maybe increase it to 10 or 15 minutes, it's generally not recommended to deviate much from the default. It can significantly impact recovery time and potentially performance.
Got it. Stick to the default 5 minutes.
Generally, yes. And it's critical to clarify a common misconception here. The Savepoint writes the updated data from memory to the data directory. It does not copy data from the log directory to the data directory.
Okay, so memory to data directory. The log is separate for transaction recording.
Exactly. The log ensures no data loss upon commit. The Savepoint ensures the main large data files on disk are consistent and up-to-date with the memory state at regular intervals. It provides a stable snapshot for rapid recovery.
And understanding the Savepoint's role is vital for consistency and faster database startup and recovery.
Yep, absolutely vital. Let's consider a couple of stark scenarios to really drive this home. Scenario 1, system crashes without a recent Savepoint.
Okay, bad situation.
Right. All your committed transactions, Eleanor Vance, John Smith, Maria Rodriguez, they're safe in the log directory. But the main data directory on disk might be significantly outdated, maybe reflecting the state for an hour ago.
So recovery means?
Recovery means loading that old, large data directory from disk, then applying a potentially massive log file, replaying every single transaction that happened since that last distant save point.
Which would take a long time.
A very, very long time. Significant, costly downtime for the business.
Okay, not good. Now, scenario 2.
Scenario 2. System crashes, but a recent save point has completed. Let's say a save point finished successfully at 8:35 a.m. and the system crashes a minute later at 8:36 a.m.
Much better, presumably.
Much better. In this case, most of your data, Eleanor, John, Maria, is already consistent and fully up-to-date in the data directory on disk, thanks to that 8:35 a.m. save point synchronizing it from memory.
So restart involves?
When the system restarts, it mainly needs to load the already consistent data directory, only the very recent changes. Maybe one new customer, David Chen, created at 8:36 a.m., who'd only be in the log directory, need to be applied from that tiny, most recent segment of the log.
Making startup and recovery much, much faster.
Dramatically faster, minimizing the impact of outages to potentially minutes instead of hours. This automatic, frequent save point mechanism is truly a cornerstone of HANA's reliability, its ability to bounce back quickly, and its overall performance.
This makes perfect sense. So the Savepoint keeps the main data files fresh, reducing the amount of log replay needed after a crash.
Precisely. And this efficient, persistent strategy log plus save points is also foundational to robust backup strategies for HANA. For the main HANA data directory holding the bulk of your business info, daily backups are standard, critical practice.
Daily full backups of the data directory.
Correct. Ensuring you have a consistent, comprehensive snapshot regularly for major incidents. The HANA log directory, however, operates on a much more frequent backup schedule.
Because it's capturing every single transaction.
Exactly. Log segments, typically small, around 10 millibeats each, are backed up perhaps every 15 minutes. This high-frequency logging and backup is critical because it enables point-in-time recovery with minimal data loss.
Okay, so daily data backups, frequent log backups.
Yes.
Yeah.
And reinforcing the save point's importance. They ensure the database's consistent state on disk, which dramatically reduces the recovery time objective, the RTO, by minimizing that log replay needed during a restart. It's a continuous, multi-layered approach to data integrity, disaster recovery, and business continuity.
The physical footprint, file system, and limitations.
Okay, so we've talked about what's happening in Memro, that super fast brain and the persistent layer saving everything to the hard disk. Now let's shift focus to the actual physical footprint on that hard disk, the specific directories making up ACON's storage structure.
Right, the physical layout.
And it's crucial to remember these are all directories sitting on the hard disk, right? Providing the physical backbone for persistence in system operation, even though HANA uses RAM so heavily for active data.
Absolutely, they're on disk.
And there are 4 primary directories we absolutely need to know.
4 main ones, yes. HANA's Data, HANA Log, HANA Shared, and USR SAP. These are where all the magic of persistence, executables, and system configs happen physically.
Okay, let's break those down. HANA Data.
This is, well, precisely what it sounds like, but with nuance. It's where the main actual database data resides. Your core business info, transactions, master data, custom tables, indexes. This is their persistent home on disk, mirroring what's in memory.
Got it. The actual data. Next, HANA Log.
As we just discussed, this stores all the transaction logs. Every committed change, updates, deletions, creations, meticulously recorded here. It also holds backups of these logs, making it critical for that fine-grained point-in-time recovery.
Right, the transaction journal. Then HANA Shared.
This is essentially the central installation directory for the whole HANA system. It contains crucial executables, the programs running HANA the kernel, which is the database core, HANA Studio for administration, config profiles, instance info, all the various HANA tools and libraries.
So, the software's home base, shared across components.
Exactly. The central hub for the HANA software itself. And finally, USR SAP.
USR SAP sounds familiar from other SAP products.
It is. It's a standard SAP installation directory, not exclusive to HANA, but still vital. It holds system-specific configs like the system ID, SID, the unique system name.
Like DE, QAS, PRD.
Right. Also the host agent for monitoring and the Solution Manager Diagnostic Agent configuration, crucial for central management. These 4 directories together form the robust physical backbone of any HANA installation.
That paints a really clear picture of the organization on disk, and that brings us to a really important compatibility point. HANA runs on.
Linux. The HANA database only supports Linux operating systems for production. You won't find it running natively on Windows Server, for instance.
Only Linux. Which flavor specifically?
The 2 primary fully supported, most common distributions are HESI Linux Enterprise Server SLES and Red Hat Enterprise Linux RHEL.
SCC and Red Hat.
Okay. Oracle Linux is also technically supported, but it's generally less common in practice.
And why only Linux?
It reflects SAP's design philosophy for performance, stability, scalability, leveraging the strengths of the open-source ecosystem, particularly Linux kernel optimizations, which are crucial for an in-memory database of HANA's scale. It's a deliberate choice for maximum efficiency.
Makes sense. And within these Linux environments, those file system sizes, you mentioned they're critical, not just recommendations.
Absolutely critical. Engineered requirements for stability, performance, recovery. These aren't arbitrary numbers. They're derived from how HANA processes and persists data. Misconfiguring these can lead to major headaches.
Okay, let's break them down. This is important stuff. HANA data size.
Needs to be at least 3 times the size of your system's physical RAM. So 1 TB RAM needs a minimum 3 TB data directory.
3 times RAM. Minimum. Any maximum.
Crucially, no upper limitation for the data directory. It can grow as your data grows, provide scalability.
Okay, HANA log size.
Needs to be half the size of RAM, so 0.5 times RAM.
Yeah.
However, there's a very specific and important maximum limit of 512 gigabytes.
Half of RAM, but capped at 512 gigabytes.
Uh,
So even if I have 2 TB RAM, the log is still max 512 gigabytes.
Correct. It doesn't become 1 TB, it caps at 512 gigabyte. This is likely a design choice to optimize log rate performance, ensure rapid commit, and make log recovery very efficient. Smaller log means faster processing.
Interesting, okay. HANA shared size.
Generally sized at 1 times the size of RAM, 1x RAM, but again, similar to the log, there's a distinct maximum limit of 1 TB.
Same logic. Even with 2 TB RAM, shared caps at 1 TB.
Correct. It won't be 2 TB, caps at 1 TB. This likely prevents excessive disk use for binaries, kernel, tools, keeps the system lean, reduces backup times for core components, ensures quick access to the software.
Got it. USR SAP.
Standard, consistent requirement of 50 gigabytes. Regardless of RAM size, it holds more static config data.
Okay, 50 gigabytes for USR SAP. And what about the backup directory? For storing the actual backups.
The recommendation for the backup storage capacity is 7 times the size of RAM, 7x RAM. So a 1 TB RAM system ideally needs 7 TB allocated just for backup storage, accommodating multiple full backups and those continuous log backups.
Wow, 7x RAM for backups. That's significant storage.
It is, but vital for proper retention. These specific limitations are absolutely crucial. They dictate infrastructure planning, hardware procurement, and ensure HANA performs optimally without disk bottlenecks. Adhering to these is fundamental for a healthy, high-performing, resilient HANA system.
Ignoring them sounds like a recipe for disaster.
It really is. Performance issues, instability, not worth cutting corners here.
Okay.
Yeah.
And speaking of those critical backups, you mentioned a default backup directory. Can it live on the same disk as the live data?
It can by default, yes, but the absolute best practice and really non-negotiable for production is to store backups on a separate hard disk.
Separate physical disk. Or network storage.
Even better, integrate with Network File System, NFS storage, or leverage specialized third-party enterprise backup tools, NetBackup, Commvault, Veeam, tools like that.
And why is separating them so critical?
Think about it. If your primary hard disk where your live HANA data lives fails catastrophically, maybe a physical failure, a power surge, if your backups are stored on that same failed disk,
You lose everything. Beta and backups.
exactly, it becomes a single point of failure no enterprise can afford. Separating backups ensures true data redundancy, physical isolation, and significantly enhances your disaster recovery capabilities. It safeguards your most valuable asset, your business data.
Navigating the rules. SAP HANA Licensing.
All right, so we've dissected ADIA's brain, its bones, its nervous system, even its physical footprint. But there's another crucial layer that dictates how businesses actually use this power and often how much it costs them.
Ah, yes, the money side. Licensing.
Let's shift focus now to the, well, intriguing and sometimes frustrating world of SAP HANA licensing. This is where tech meets finance.
A critical meeting point.
So when you first install HANA, it doesn't come with a permanent license right away.
Correct. By default, when you install, you get a temporary license. It's valid for 90 days.
90 days, like a grace period.
Exactly. Gives you time to get the system up, configured, tested, ready for long-term use. However, it's absolutely essential that a valid permanent license is procured and installed before that 90-day temp 1 expires.
What happens if you miss the deadline?
It can lead to serious operational issues, system instability, potentially even shutdowns depending on the version and configuration. Not something you want to happen.
Definitely not. And these permanent licenses, they're not actually forever, are they?
Good point. They aren't permanent in the sense of lasting forever. They have a defined expiry date, typically a few years out.
Okay, so they need renewal. What if you reach that expiry date on your permanent license?
If you reach the expiry date without proactively renewing and installing the new license, the system won't just stop dead immediately. Instead, it automatically installs another temporary license.
Another temporary one. How long does that last?
This one is only for a brief 28-day period.
28 days. That's not long.
It's not. It's SAP's crucial buffer, a stark warning period, designed to give you a chance to rectify the situation. But, and this is critical, you absolutely do not want to rely on this 28-day temp license, especially for production.
Why not? It gives you some time.
Because it puts your business at unnecessary and critical risk of disruption. You should always apply for and install a new permanent license renewal proactively, well before the existing one expires. Waiting for that 28-day window is just asking for trouble.
Got it. Be proactive with renewals. Don't wait for the warning. Now, a key factor in HANA license costs is memory usage.
That's the core metric, yes. The amount of RAM your HANA system actually consumes for active data directly impacts your ongoing licensing fees.
So more RAM used means higher license cost.
Generally, yes. This makes proactive memory management not just a performance consideration, but a critical financial one, too.
And companies often overlook this ongoing cost implication.
Sometimes, yes. They focus on the initial investment, but forget that data grows. You need to continuously optimize your data footprint, archive old data, manage growth to avoid spiraling license fees. It's not just an IT problem, it's a strategic financial challenge impacting your SOC sale. Total cost of ownership, your TCO.
Right, TCO. That makes sense. Now, you mentioned there are different types of permanent licenses.
Indeed, and this is a really crucial distinction. There are two main types, each with very different behaviors and consequently very different operational and financial implications. The enforced license and the unenforced license.
Enforced versus unenforced. Okay, let's start with enforced. What does that mean?
Let's use an example. Imagine you have a server with, say, 400 gigabytes of physical RAM installed. But for cost reasons, maybe you've purchased an enforced license for only 256 gigabytes.
Okay, 400 gigabits available, but licensed for 256 gigabytes. Enforced.
Right. The behavior with an enforced license is exactly what the name suggests. If your database's actual memory usage reaches that licensed 256 gigabit limit plus maybe a tiny 1 to 2 gigabit tolerance,
What happens?
the database will go into a hang state. It becomes unresponsive. It stops operations.
Stops completely, like crashes.
Effectively, yes.
Yeah.
For any business, this is catastrophic. Immediate impact on production, users, critical processes.
Wow, how do you fix it?
You need immediate license renewal, which often requires a system restart, more downtime, or you have to take urgent memory-saving actions like aggressively compressing tables or offloading data to get back under the limit.
Sounds stressful. How do you know if you have an enforced license?
You can usually identify it in system screenshots or license reports. Look for the license type HANA EN. The ENF clearly indicates it's enforced.
HANA NF. Got it. Okay, now compare that to the unenforced license.
Right. Let's use the same scenario.
Yeah.
400 gigabit of physical RAM, but this time a 256 gigabit unenforced license.
Yeah.
If your memory usage reaches or even exceeds that license to 256 gigabit threshold, the database will not stop.
It keeps running, even past the license limit.
It keeps running. It allows usage up to the full physical RAM available, so all 400 gigabits in our example. What it will do, however, is diligently throw warning messages, critical alerts in the system logs and monitoring tools.
So it warns you, but doesn't shut down.
Exactly. It flags that your licensed memory limit has been reached and that a renewal or memory optimization is needed. The massive advantage here is that it gives you valuable time to proactively renew the license or implement memory saving strategies without that immediate business impact, without critical downtime.
That sounds much safer for production systems.
Absolutely. For this reason, the unenforced license is highly recommended for production systems. Downtime there can lead to huge financial losses, reputational damage. Having that buffer and grace period is invaluable.
And how do you identify this one?
It typically shows up as just HANA without the ENF suffix.
Yeah.
This raises an important question, though. For any organization, how would you decide which type is right? Balancing the perhaps slightly higher cost of unenforced against the risk of enforced. It's a key strategic decision.
It really is. So just to summarize that critical difference, enforced means the system stops or hangs when you hit the memory limit. Boom, operations cease.
Correct. Hard stop.
Unenforced means the system keeps running, but it gives you clear, urgent warnings to take action.
Right. A graceful warning, allowing you to respond without panic. It highlights how licensing isn't just about compliance, it's fundamentally operational.
Absolutely. And regardless of which type you choose, when you actually generate that permanent license from SAP, they need specific details from your system, right?
Precisely. To ensure the license is unique and correctly applied, SAP requires specific identifying details. These typically include the system ID, the SID.
The DEVQASPRD name.
Right. Also, the hardware key, which is a unique fingerprint generated by the server's physical hardware, CPU, network cards, etc. Think of it as the server's unique ID card.
Okay, SID and hardware key. Anything else?
And your installation number. This links the license to your specific overall SAP customer count.
Got it. SID, hardware key, installation number.
These details act like a digital signature, ensuring the generated license is valid only for your specific AJA installation, preventing unauthorized use and ensuring proper tracking. Outro.
Wow. What an incredible journey through the layers of SAP AJA today. We started right back at its, well, surprising genesis and rapid evolution from that audacious idea in 2006, general availability in 2011, and its pivotal role as the non-negotiable foundation for S/4HANA, really changing SAP's whole direction.
A foundational shift.
Then we peeled back the layers of its architecture, exploring that critical distinction between single and multi-tenant deployments, understanding how one instance can host multiple tenants, especially for non-production landscapes.
And the performance trade-offs involved.
Exactly. Then we dove into the very brain of HANA, its defining reliance on RAM, and that ingenious persistent layer with the data and log directories, all underpinned by that absolutely crucial Savepoint mechanism ensuring consistency and rapid recovery.
Can't overstate the importance of save points.
We navigated the physical footprint too, data, log, shared USR SAP directories on disk, and those vital non-negotiable file system size limitations. So critical for planning.
Absolutely. 3 times RAM for data, half for log capped at 512. Crucial details.
And finally, we dissected the critical world of SAP HO licensing, demystifying temporary versus permanent and that stark business-critical difference between enforced and unenforced licenses, a choice that literally means seamless operations versus potential catastrophic downtime.
Indeed, this deep dive really provides, I think, a unique and vital lens into what is a complex but utterly essential technology. For anyone working with, managing, or even just interested in modern enterprise systems, understanding these fundamental concepts of SAP HA is invaluable.
It really goes beyond just definitions, doesn't it?
It does. It's about grasping how SAP HA revolutionized data processing and ERP by fundamentally changing how data is stored, accessed, and managed. If we connect this to the bigger picture, it shifted the paradigm from slow, disk-bound batch processing to real-time in-memory insights.
Enabling businesses to react faster, innovate quicker.
Exactly. Gaining competitive advantage at unprecedented speeds. It truly transformed the landscape of enterprise IT.
Absolutely. And as we wrap up this deep dive, I want to leave you, our listener, with maybe a provocative thought to consider. If HANA demonstrated the profound power of in-memory computing and the efficiency of multi-tenancy within SAP's world, how might these continued evolutions shape the future of cloud infrastructure and data management beyond just SAP? What new challenges, what new opportunities might that bring for managing performance, ensuring data governance, perhaps even more dynamic licensing models in our increasingly connected world?
Interesting questions.
And what other surprising dependencies, what critical architectural nuances might be hidden within the complex technologies we rely on every single day, just waiting to be discovered? We really encourage you to continue your own deep dives into these fascinating questions. And, well, we'll be here with more insights next time.